Over 80% of people with disabilities use an assistive device, and 27% need at least one more, often citing cost as a barrier. Makers Making Change is helping bridge that gap. Our community of volunteers design and build assistive technologies you can download and request on our website. If you're looking for a solution, you can browse through our wide variety of devices, like simple bottle openers, assistive switches, and even more high-tech options like adapted toys and the LipSync. Once you've submitted a request, a volunteer maker will respond and collaborate with you to build the device. The best part of this volunteer platform is that you only pay for the cost of materials, no markups, and no inventory fees. Want to volunteer? We're open to makers of any skill level. Learn more and join the movement today at makersmakingchange.com.
Hello, everyone, and welcome to another episode of MMC Live. My name is Jake. I'm the engineering lead at Neil Squire's Making Change program. Oh boy. In today's episode, the focus again on R&D. Today, we'll be highlighting a new device submitted by the community into the library, providing updates on a few of our projects, and wrapping up with another Open AT design tip. We'll start off with a new device in the library that was created and submitted by Alberta Health Services. So this is a set of adaptive utensil handles, and these are for the IKEA Identit utensil set. So on the website here, under assistive devices, it's number 1. Get a live action today. So if you haven't seen this before, this has all the information for a particular device. This one talks about who the device is for. So this one's specifically helping people to eat more independently. So some people have difficulty grabbing a fork or a spoon. And this is a really cool modular set of handles that helps someone find something that's going to work for their abilities. The estimated cost for this one is between $11 and $25, and that's really because we need to buy a whole set of utensils. Each one, if you're building more, is down sort of less than $5 for per utensil and per the different handles. This is a good example of someone in the community that's taken our documentation templates and really explained all the information that's needed to use, to build, and to improve upon this device. So once you log into the site, you can either click the big blue button to request a maker if you want to have someone collaborate with you and build this for you. Or if you have the skills, you can build it yourself. We can pop down here. So like many of our projects, we'll use this as an opportunity to kind of look at the GitHub portion a bit. So when you first see that, you'll see some basic information here. Some pictures, sort of corresponding complementary information for how this works and how to get it. All the documentation is listed here. So there's some information from the designers about why they did particular choices and the tests that they made. There's a maker guide that outlines all the steps that are required, a bill of material that lists out all the costs, and a user guide. So we'll have a look at the maker guide first. So we can see this runs someone through the whole process of sort of what they need to do to talk with the maker, what they're going to give to the user when the process is all done, some information on the different supplies, some information on how to do the different printing. So for this one, it seems like a big long list, but this is because all of those different handles are listed out here. It might be good for someone who's doing some evaluations to have the complete set. Otherwise, a particular user might just need 1 or 2 of these. And then once you've got all the parts together, it'll walk you through step by step on how to assemble it. So we can see here, these are all kind of the components that are required, including all the different handles. And then this one's really simple. We stick the fork or the spoon into this clever sort of core portion that folds over and grabs onto it. And then that gets inserted into one of those handles. And the other interesting thing about this design is it allows a bunch of different adjustments. So you can change the angle to really customize it for the user. And like any 3D printed thing, it can be done in a range of colors and different materials. For the user, there's some information here about, who it's intended for, the main features, how to adjust it, so how to make sure so you can adjust that angle, as well as how to clean it and how to dispose of it. So really grateful to Todd and his team at the Research and Innovation through Glenrose for taking all their design and effort that they had done internally and making this a great fit for the community and working through all the documentation piece. So very happy to have that as part of our library. Okay, that's good on that. Next, we have Stefan, and he's been working away on what was called the auditory scanning device, and that is a mouthful for something that's supposed to talk. So we'll talk right now about the Chatterbox.
Hello, this is a demonstration of the Chatterbox. It is an auditory scanning device for people with complex communication needs and visual impairment. So it allows them to communicate with people by playing back pre-recorded messages, and it plays the audio of that message to let them know which message they would be selecting as they go through with switch scanning. So I'm going to demonstrate some of the basic functions of it today. So there are going to be 3 different levels, and on each of those levels there will be 4 messages that you can record. So I won't demonstrate the different levels today, I'll just demonstrate the different messages. So there will be 4 direct access buttons, so these are these buttons here. Those will be on the device, and they allow someone to directly access each message, so they can play the specific message if they want to press that button, or they can use that button to record a new message in that place. So if they want to play the message, they can just press the button, an LED will light up to indicate which message it is, and the message will play.
Message 1.
So if they want to switch scan, that's what these 2 buttons here are for. And on the actual device, those will be jacks, so you can plug in an assistive switch that works for the person. And it works with single or 2 switch scanning. So 2 switch scanning would allow them to advance to the next message at any time, but if they're doing single switch scanning, that allows them to start the scanning, and then it'll automatically advance to the next messages until the person selects the message they want to have replayed. So I'll just demonstrate that now.
Message 1.
So the LED will stay on to indicate it'll still be message 1.
Message 2.
And the delay will be adjustable.
Message 3.
If they want to replay the message, they just hit that
Message
button
3.
again. Or if they want to skip through the messages instead of waiting for that delay,
Message 1.
they can hit the other button
Message 3. Message 4.
to jump through the messages.
Message 4.
Now, if someone wanted to record a new message, they can hit a switch, which is just up here. And to let them know they're in recording mode, all of the message buttons will start blinking at them. Then if they want to record a new message on, say, that message 1 slot, they can hold down that message 1 button, recording message 1, and as that individual LED starts blinking and the other ones go off, that lets them know that it's time for them to be able to start recording that message. If they want to preview that message they've just recorded before going back into playback mode, they can just press that button again.
Recording message 1.
And they can also preview the other messages.
Message 2. Message 3. Message 4.
And to go back into switch scanning mode, they can just hit that switch again, and it goes back into switch scanning mode, which is indicated by none of the LEDs being lit up or flashing. Thanks.
Great, thanks, Stefan. You can see there a bunch of breadboarding and wires and microcontrollers, which is a good sort of like prototype level sort of way to test the firmware code as it gets developed, and that's been the focus lately. In parallel with that is the enclosure and the sort of pretty boxes, so that the end user won't look at a big scattered mess of wires. It'll be a nice, clean, tidy box. Speaking of microcontrollers and firmware, so oftentimes we need to change the code or update the code to either fix problems or add features. So next up, Derek's going to run us through how we do this to change code on a microcontroller for a new device or for one that needs an update.
Hi, I'm Derek Andrews, the electronics technician for Makers Making Change. Today we'll be flashing LipSync Hub firmware using Arduino IDE. First, you'll need to download and install the Arduino IDE for your operating system. Click on File and choose Preferences. Locate the text field that says Additional Board Manager URLs. Copy and paste the shown Seed Studio link into the field as a new line. Now we'll install the microcontroller's own specific board code. Open the Boards Manager. Choose the option from Tools, Board, Boards Manager. Search for Seed NRF52 and select Seed NRF52 boards by Seed Studio. Click Install to install the board. Next up, we'll be installing libraries for sensors and other connectivity. In the Arduino IDE, go to Tools, Manage Libraries. For each of the libraries in the table below, search for the name and click Install. If prompted to install any dependent libraries, click OK. If you get a message about installing dependencies, click on Install All. Open LipSync firmware.ino with Arduino IDE. Select Seed Xiao NRF52840 from Tools, Board, Seed NRF52 boards. Connect the LipSync using the USB cable to the computer. Select the correct port from Tools, Port menu. Verify and upload the code. Unplug and reattach the USB cable from the hub. The display should show the word LipSync, an indication of a successful installation. Thanks for watching.
Thanks, Derek. While that was sort of specific for the LipSync firmware, which we did a lot of this spring as we rolled out our sort of major firmware update, those instructions will be quite similar for any other device that has a microcontroller. And don't worry if it seems like a lot. The step-by-step instructions for everything from installing the Arduino to figuring out the libraries and boards, those will all be laid out step-by-step in a maker guide for a device that uses a microcontroller. Of the devices that use microcontrollers, a big one of them is the LipSync hub. Other ones are sort of general interfaces for capturing some sort of thing in the real world and making it talk to a digital device. So Brad here is joining me today, his first time on MMC Live, and he's going to talk about hubs and digital interfaces. Take it away, Brad.
Hi, thanks for having me. What I want to talk about today is something called a digital switch interface. We have a lot of assistive switches on our site, but by themselves, they can't be used with a computer or any other digital device. Because of this, if you want to use an assistive switch with a digital device, you're going to need something called a switch interface. A switch interface is a device that, at its simplest, converts the signal from the switch into something that a computer can understand. This can be as simple as sending a single keystroke when the switch is pressed, to as complicated as using two switches to type using Morse code. Almost all switch interfaces accept a 3.5 millimeter assistive switch and can potentially also accept analog 3.5 millimeter joysticks, USB joysticks, DB9 joysticks, as well as various other wireless buttons and joysticks.
Brad, I'm just going to hop in here for a second. Looks like your screen share is not showing us the slides.
All right. Sorry about that.
We're doing it live, folks.
Doing it live. This again here, or do you want me to just talk to it live without the pictures?
Maybe if you just want to talk through it, we can just take off the screen. It's just we're looking at your PowerPoint thing, not the.
All right. One last idea here. Sorry. Just do the entire screen. Does it look good?
There we go. Perfect. Go ahead.
All right. Sorry about that. There are sort of 4 different main use cases for switch interfaces. There's switch scanning, there's cursor control, there's keyboard emulation, and there is adaptive gaming. So switch scanning is one of the most popular switch interface use cases. With switch scanning, one or more switches can be used to scan through items on the screen and select the desired one. Switch scanning can be done with as few as 1 switch, and it generally works by sending keystrokes to the connected device when the buttons are pushed. Different switch scanning software look for different keystrokes, so most switch scanning interfaces can use several of the most different sort of sets of keystrokes. Another thing that digital interfaces can be used for is cursor control, both on a computer or on a mobile device. There are a lot of different ways to move a cursor with a switch interface, from moving the cursor with a joystick and clicking using switches, to moving and clicking entirely with switches, and using 2 different switches to move and click using Morse code. These switch interfaces can also be used to type by opening an on-screen keyboard and typing using the cursor. So switch interfaces can also be used to emulate a keyboard. Since it isn't really practical to have a switch for the 50-odd keys on a keyboard, most switch interfaces either have sort of a limited selection of keystrokes like space, enter, tab, shift, and backspace that allow the user to navigate through web pages, or allow the user to type using Morse code with 2 switches. If you're a regular watcher of MMC Live, you probably already know about adaptive gaming, but for those of you who are tuning in for the first time, adaptive gaming is using accessible switches and joysticks to play video games. A digital switch interface, such as the Xbox Adaptive Controller, or XAC, can be used to connect a variety of switches and joysticks to a computer or other device to create an accessible game controller that works for the user. At the moment, we have quite a few digital interfaces in the MMC library. Right now, we have the LipSync hub, which can also be used as the Willow hub, the Forest hub, the Freedom Wing, the Rocket Switch interface, the Enable controller, and the Enable controller mini. Each of these switch interfaces has a different use case and would be ideal for different users. When you're looking for a switch interface, it can be pretty hard to determine which would be the best for you when there are so many options that do so many different things right now. So right now, we're working on an updated switch interface selection guide to help you determine which switch interface works the best for you. This new switch interface guide should be available this summer to help you pick the best switch interface for your needs.
Great. Thanks, Brad. Yeah, switch interfaces are one where the commercial ones can be quite expensive. And it's a great way to sort of bridge that simple switch use from, adaptive toys to that digital access. So thanks for that, and looking forward to that updated resource. As part of that process too, we'll be looking at adding at least probably one more version to the library and then seeing if we can consolidate or simplify things. So myself and Brad will be definitely interested in any feedback you have for what use cases and what sort of features you'd be looking for in an open source version of those pieces. Cool. Thanks, Brad. Next, Open AT design tip. So our tip today comes from Josie. I'm talking a bit about design for manufacturing, in this case, design for 3D printing.
Today's Open AT design tip is about designing for 3D printing, and specifically how to design parts that successfully print floating holes without supports. When designing parts, it is important to consider how they are going to be manufactured. For most devices that we design, that means FDM 3D printing. In FDM 3D printing, each layer is built onto the layer before it, so we can't print where there's no material underneath. This includes floating elements, large overhangs, and unsupported holes. Typically, supports are used to allow us to print these floating elements. Supports are temporary structures that are printed with the part to provide a surface on which to print the floating element, and are then removed by hand once the print is finished. When designing for 3D printing, it is a good idea to consider ways to reduce the amount of supports in your print. This can reduce print time, reduce post-processing of parts, improve the surface finish, and save on material, which is both cost-effective and better for the environment. One situation where prints often do not print successfully without supports is floating holes. There are many situations where you might want to include this in a design. One that is common is screw holes with a countersink for the screw head, like shown here. You can see how this unsupported hole did not print very well, and there is some filament to be cleaned up. To avoid using supports, we are going to make use of a technique called bridging. This is the process of printing a horizontal, unsupported span between two supported points. However, when bridging, each path for the 3D printer must be pretty much straight across, so we cannot print this unsupported hole without some modifications to the design. To modify the design, we are going to add small rectangular extrusions that allow us to do a small section of bridging and then another small section of bridging on top of that. So what this looks like is creating a sketch on the bottom plane of your unsupported hole and adding lines tangent to the hole on two opposite sides, like this. Then create another set of lines that are tangent to the hole and connect the first two sets of lines together, like this. Then you want to take the entire middle section shown here and extrude cut the depth of one layer height, which in my case is 0.2 millimeters. Then take the innermost square around the circle and extrude cut this section the depth of two layer heights, which in my case is 0.4 millimeters. Now we have two sets of rectangles that will allow us to do two sets of bridging. Now let's export this and take a look at it in our printer slicer. See how the layers print with the first set of rectangles forming a bridge, then the next set forming a second bridge, and then the circle printed on top of that. Now this will print without any supports and with good print quality on the bottom surface of this hole. See these two photos side by side? Both were printed without supports, but the one on the left was designed without using this trick, and the one on the right does use this trick. You can see how much better the print quality is and how the one on the right does not have any filament that needs to be cleaned up afterwards. That is how you design for unsupported holes in 3D printing. If you want to learn more or see other design tips, this and more can be found at Hydra Research under Learn and then under Design Rules. Thanks for tuning in. Catch you next time.
Oh no, did that just cut out? You're just getting to the juicy part. So the last bit of that video talks about the larger section. We want to remove or extrude it one layer height into the part. And then the smaller sort of inner square section gets extruded 2 layer heights into the part. And so what that does is it sort of provides a bit of structure and framework. So you bridge straight across one way, then you can bridge across the other way. And then when it goes to print the circle on that sort of third layer, it does a much better job. It doesn't have to go quite as far. That resource that Josie mentioned there, the folks at Hydra Research, they have a whole sort of list of a bunch of different best practices. So I encourage you, if you're keen on this kind of stuff, have a look. There's other resources out there, but that's a pretty good one and gives some good explanation on how to do these different pieces. For us, we think that's important because it makes it easier and more reliable for our prints to print, as well as all the sustainability pieces of, reducing failed prints, reducing unneeded support material, and those things. That takes us it for today. That's all, folks. So if you have any feedbacks or suggestions, please let us know for future episodes. We're taking a bit of a pause over the summer, so the next episode, resuming with the outreach team, will be on September 24th. In the meantime, please stay in touch, and you can reach out to us through the website or get in touch with the community. We now have a Makers Making Change community Discord. We'll make sure those links are sent out. So if you want to chat about this stuff, ask questions, find out about what's going on, that's a great place to do it. Thanks, everybody. See you next time.